Hello, geometry geniuses. I'm Mrs. Long, and today we're going to talk about right triangles and trigonometric ratios. How do I identify the parts of a right triangle, and how do I find trigonometric ratios? Now, if you have been to the class notebook or the OHS, you can actually download this very same graphic organizer that I'm going to use in this presentation so that you can follow along with me, and then you'll have a reference guide or a graphic organizer to go along with your notes. All right, so I'm going to look at this little diagram with the hippopotamus down here. And the first thing I want you to notice is that they have identified a reference angle down here. And so all of our parts are going to be in relation to angle A. Where is this side in relation to angle A? So first I want to talk about our hypotenuse. Hypotenuse. The hypotenuse is always the longest side on a right triangle, and it is always directly across from the right angle. Across from the right angle. Now, I like to color code mine, so if you have colored pencils, or crayons, or markers, or whatever, I always do the hypotenuse in purple. Notice that it is directly across from my right angle. Here's my right angle. There's my hypotenuse. Okay? They call it a hypotenuse in this diagram just to be silly and to help you remember that that's where it is. You're going to need the longest side if you're going to put a hippopotamus on it, right? You can't be using any short legs. You got to have the long leg to lay that big old hippopotamus on. All right, the next thing I like to do is I like to pretend like I'm taking a squirt bottle. So here's my squirt bottle. And I'm going to squirt right here in my reference angle. Now, when I do that, the opposite side is going to be the side that gets wet. So I do it in blue to remind me that it's the one that would get wet if I were squirting in that reference angle. Opposite is across from the reference angle. Alrighty-dighty. All right, then the one that's left over, the one we haven't identified yet, is the adjacent. Okay, that's adjacent. Now notice that the adjacent side touches or forms the vertex of the reference angle, helps form the vertex of the reference angle. So it'll be the hypotenuse and the adjacent form that angle of the reference angle. So if you can find all those parts, you are well on your way to being able to find trigonometric ratios, reference angle. All right, so let's take a look at that. Trigonometric ratios are sine, cosine, and tangent. There are more, but those are the ones that we're learning about in this course. So we're learning about the sine, the cosine, and the tangent. Now, we learned a little mnemonic device, SOHCAHTOA. All right, you ready? And I always beat on my desk when I say it because it just kind of helps me remember. SOHCAHTOA, SOHCAHTOA. Now, if you're sitting at home by yourself, go ahead, bang on your desk, say it to yourself. If you're not home by yourself, you might want to wait till you are so everybody doesn't look at you funny. But it's SOHCAHTOA, SOHCAHTOA. Now, why do we do this? Why do we go through all that? Well, here's the thing. It's hard to remember which side goes with which when we're starting to make ratios. Remember, ratio is kind of a fancy word for a fraction that compares two things. And when we do trigonometric ratios, we are comparing side lengths. So stands for sine, and it is made up of the opposite over the hypotenuse. Opposite over hypotenuse, okay? So if I wanted to find that in this particular triangle, I would need to identify those parts first. So this is my hypotenuse. And we're going to be talking about angle T over here. If you notice in the next column, we're going to do the example. So we're going to be finding the sine of T, which is this angle here. Well, if that's the case, my opposite side, the opposite side is going to be this blue one over here. And so I'm going to label it opposite. And then this guy here is the adjacent. All right, I'm going to pause you just a second. You probably won't know the difference, but I am going to pause you just a second. All right, so now what I'm going to do is all I have to do is I have to look over there and I have to find the length of the opposite side, which I can see is 5. No, I'm sorry, it's 7. There it is right there. The length of the opposite side is 7. And the length of the hypotenuse is 25. And there we go. I have now changed that into a sine ratio. I've now created a sine ratio. Occasionally, they're going to ask you to put this in decimal form, and all you have to do there is divide the top by the bottom. So I would just put in my calculator 7 divided by 25. And I get 0.28. So if I wanted to write that in decimal form, I would write 0.28. That's not too bad. Now, like I said, there are 3 trig ratios that we're going to concentrate on. The next one is c, which stands for cosine. The A stands for adjacent. Let me grab my red pen again. The A stands for adjacent, and the H stands for hypotenuse. So you can see how this mnemonic device, SOHCAHTOA, really comes in handy. So we're using the same triangle, and we have the same reference angle, so I'm not going to sketch all that out again, but I know that my hypotenuse is 25, the length of the hypotenuse is 25, and the length of the adjacent side, and let me just circle it up here so you can see where I'm getting that, the length of the adjacent side is 24. So again, if I wanted to turn that into a decimal, I would just do 24 divided by 25. 24 divided by 25, and I get 0.96. So that if they ask me for the cosine of t, I would have to look at my answer choices to see if they wanted it in fraction form or decimal form. All right, and then the last one we're going to talk about is TOA. TOA, that stands for tangent, and tangent equals the ratio of the opposite side over the adjacent side. So I'm going to go back and grab my blue for opposite. So opposite here is 7. The adjacent side is 24. Whoops, I'm sorry, I put this in the wrong place, didn't I? So this is 24. This should say adjacent. All right, let me go back and grab my blue and fix that. This should say opposite here. Looks like I'm going to have to do a little erasing, doesn't it? All right, so opposite is here. And we said that was 7. So again, if I wanted to change that into a decimal, I just divide the top by the bottom. 7 divided by 24. Oh, and I get a big decimal here, and I'm glad that that happened because what I want to show you is I get this big long decimal. I'm going to round it to 4 numbers after the decimal. So I'm going to start with 0 point, and now I need 4 numbers. So I'm going to go 2, 9, 1, 6, and in this case the 6 is repeating, so I'm just going to put the little repeating bar over it. So 0.2916. Okay, so we have to know the parts of the right triangle, and then you need to just know these ratios. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. We remember that by this little mnemonic device, SOHCAHTOA, SOHCAHTOA. So go do your rain dance and practice some trig. Have a great day, guys.